Hey everyone, it's Kyle here, and in this week's C program tutorial, we're learning about the switch control structure. We've learned about a lot of control structures so far. We started with the if-else statement, and then we learned about 3 different types of loops. Now for the final control structure that we'll be learning about, we're talking about switches, which are a way in which you can use logic to control your program's flow of execution in a whole bunch of different ways. Where an if-else statement could get you 2 or maybe 3 different ways to branch off, a switch can give you an elegant and clean way to get your program to branch off into really as many different directions as you want based on, say, a sensor value or some other control. So I think that's enough yammering for now. Let's go ahead and learn about the switch. Let's take a look at how we make a switch in C. The first thing I want to do is I'll just initialize a variable so I can show you how the condition works. So the easiest way to conceptualize switches is to think about some kind of sensor that has some kind of numerical value. And so we'll just initialize this to 0 right here. And then the way you go about starting your switch, right, you first have to write switch to initialize it. And then you're going to need to give it some kind of expression. So let's say we're reading the sensor, so we have our variable sensor equals, and we have some command, say read sensor. Of course, this is not a real command. Maybe you have it defined as a function in your program. We'll learn about that later. But just imagine conceptually that our code is going to be reading the numerical value from an imaginary sensor, and that numerical value is going to be recorded in the sensor variable that we've already initialized. Now what we do next is you need to outline the body in these curly Q brackets, and what the switch now does is it evaluates that value that's being read by the sensor and stored in that sensor variable, and it's going to run one of the cases that you define, and you're going to program a case for each of the possible sensor values that you want your robot to react to, and then within that case tell the robot what instructions you want it to execute when that case happens. So what does this look like in practice? So what we're going to do is we're going to make our first case. So you do that by typing the word case, and then you need to give it some kind of label. So for example, like this is the condition where the case executes. So I could say sensor equals 0. So if the sensor reading equals 0, that'll be when that case executes. And then end that statement not with a semicolon, but with a regular colon, which signals to the compiler that we've just defined the condition for a case. And then what you can do afterwards is then you put your statements, the code that you want to execute, so then you can have it do something. And then if you want to make another case, you just simply write case under that. So if the sensor reading equals 1, colon, something else can happen here. And then you can keep going like that. I want to draw your attention to one extra functionality of the switch, and that is the break statement, which if you choose to add, you will add at the end of the case like so, and you'll put like a semicolon after that. Now, why would you choose to put a break statement in there? What the break does is when it gets to the end of this case now, without the break statement, what can happen is the switch can do something called falling through. And what this means is if, for example, if we read the value from the sensor and the sensor value was 0, it would execute these code statements. But if one of the other cases was also true underneath it, it could then move on and execute the next case that was true. Now, sometimes you might want this to happen, or sometimes you don't. So if you only want the switch to execute one case each time it comes around in your loop, for example, if you were in a loop, or if you only want it to execute one of the cases, then you're going to have to add a break statement at the end. And generally, I'd say if you're not sure whether or not you want, if you're going to need the break statement or not, as a general rule of thumb, most of the time you're going to need to use the break statement. And then one final thing I want to tell you about is that you can also define a default case, and you do this by actually typing the word default and putting a colon after that. And then you can put your statements, so here tell it to do something. and then you could choose to put a break after that if you want. But what the default does is this is the case that executes if there's no reading on the sensor. So in this case, the way we set it up, it doesn't really make sense in context. But if you had a certain set of values defined, so for specific cases, so for 0 and 1, now if our sensor reads a value that's not 0 or 1, what is the switch going to do? Ordinarily, it's just going to pass completely over the switch and not execute anything. But now that we have this default case, if the sensor reading doesn't match any of our defined cases, it'll just default to this default case and then run that code there. So that's pretty much how the switch works. It is possible to get most of the functionality of a switch by using a whole bunch of if-else statements, which we talked about in last week's tutorial, but that's just a terrible way to program. I don't recommend that unless you specifically need if-else statements for what you're looking for, just because the if-else statements get messy and it's just sloppy programming. The switch exists to simplify that problem and make your code a lot easier to read, neater, and cleaner, and also execute faster. I want to show you an example of what a switch looks like in context. So this is a simple remote control program that I made for an EV3 robot. So it uses an infrared sensor mounted on the car to receive the signals from an infrared remote. These are all just functions to define things the car does. But the meat and potatoes of this program happens inside of this while loop where we have a switch. So inside of this switch, right, we have get IR remote channel buttons, which is where I'm telling the robot to read the button that's being pressed on the remote, and then we define a case for each of the possible buttons. So if none of the buttons are pressed, which I could have also just called a default case, we have the robot stopping and centering its steering, and then I have a break because I don't want the switch to execute any other commands, so it'll just skip to the end of the switch. And then in this case, since I have a loop, it'll come back up to the top and see if the button state has pressed. So if the person controlling it has pressed a different button. And in this case, so if just the red button is up, then we know the robot should drive forward, so the left and right motors go on full power, and then the steering centers, and then there's a brake again. And you see there's a case for each of the individual button combinations, and the robot is programmed to respond to each of them within the body of the switch. And so that's what a switch might look like in context. Thank you for watching my tutorial this week. If you haven't already, click here to check out my new book. It's called Building Smart LEGO Mindstorms EV3 Robots, and it's now available on Amazon. If you found this video helpful, be sure to subscribe to my channel for more tutorials like this every Thursday. And if you have an idea for a tutorial, drop your suggestion in the comment section below. Thank you for watching, and I'll see you next time.